water. What we changed is the type of heat. So we did the first one, radiation. By the way, this would make a great science fair project. The first one we heated using the sun's radiation. And of course, that would vary depending on what time of the day it was and what time of the year it was and what season it was. But we heated up the sand and the water with, and then we heated up the sand and the water with conduction from a hot plate. And we decided, well, let's see convection of sorts. It's sort of a convection because it's in a freezer, but it's still, I'm not even really sure what type of heat transfer it is. I guess it's definitely convection, I would have to say, because the sand is not touching the freezer and the water is not touching the freezer, and the water and the sand are not, they're not radiating heat. Well, they are kind of radiating. Maybe that's it. Maybe I just talked myself out of the convection. It's radiation, but it's on a much smaller level than the sun. So the heat is radiating away from the sand, away from the water on a much smaller scale. So the water and the sand is now our heat source. Does that answer your question?
Yeah.
All right, now we got one more over from Armand. Over here. Say it loud.
From who?
Armand.
Oh, I thought you said our mom. Okay. Okay, hold on. Can you put that question on hold for just 1 second? Because I have to take a reading in 5 seconds.
Okay.
So we got 5.7.
Oops.
We've got negative 16.8. And we've got 1.0. So after 30 minutes from 22.2 degrees Celsius all the way down to 5.7 degrees Celsius, the freezer started at negative 16.5. And I opened the door and that warmed it up. And now that the freezer's closed, what is this? Okay. And then sand is all the way down to 1. So if you look at the data sheet, if Mr. Gordon shows it to you,
I'm dual
you're gonna
screening.
see
We
that
got both of it. We got it both showing right now.
that's what I've got too. I've got dual screen.
So I'm using my laser pointer and showing them. So go ahead and talk, and I'll point that out for them.
Okay, so we started, the initial temperature was 22.2 degrees for water. And the freezer started at negative 16.5. And the sand started at 20.7 degrees Celsius. Then I opened the freezer door, warmed up by nearly over 3 degrees here. It went to negative 13.3. So nearly 3 degrees. And so water started to get cold right away after 5 minutes. So of course this is after 5 minutes that these temperatures are taken. And then after 5 minutes again, class, I'm talking. Thank you. Then after 10 minutes, we had these readings. And then after 15 minutes, and then 20. I just realized with the time delay, I need to slow down.
No, I got it.
And then after 25 minutes, we have this. And this is our latest readings. And so I had my students predict which one would lose heat fastest. Would it be sand or water? Which one would lose its heat the fastest? Which one would transfer heat from its material to the refrigerator? So does anybody have a prediction based on what we're seeing?
Right. Cheyenne? Say it louder.
Water.
She predicts water.
She predicts water what?
Would transfer heat faster. She says the water will transfer the heat faster.
So when it transfers heat from the water to the freezer, that means the water temperature is going down, right?
Yes.
Okay. So are you looking at the 30-minute data sheet or data info?
Yes. So we're looking at these here. These here.
Look where we started at initial and look where we are now.
So which one is greater? Greater difference. Transfer. The sand. So why do you think sand? Can you repeat the question, Mr. Young? We're a little confused on what the question is.
That water will lose its heat faster.
Sand or water,
Look
you
at the
said?
data and see if the data matches her statement. So when we look at, excuse me, class, I'm talking. When we look at where we started with water, it was 22.2 degrees Celsius.
Where we are currently is this right here.
And after 30 minutes, it's now down to 5.7 degrees Celsius.
So look at the sand.
So 22.2 minus 5.7 would be the change in temperature. We call that delta. So the change in temperature was from 22.2 and then it went to 5.7 degrees. Which one is warmer? 22 or 5.7?
Everyone?
5.7.
Warmer.
Wow. I heard
Warmer.
2.2 degrees Celsius is quite a bit warmer than 5.7 degrees Celsius.
We're
So the
learning
water
your
is
teaching
cooling.
style.
We are seeing that. However, let's look at sand, the difference in sand. 20.7, and it's now at 1. So its delta, temperature change, is 19. So that's a big change. Sand got cold really fast. And if you look at our video screen, water's dropped already. Freezer's warming up. And we still have about 2 more minutes before we take our next measurement.
Sand is currently at 1.0. So a student posed a question: do we think sand can sand go any lower? Because it has not changed.
Oh, that's a great question. Has it maxed out? Is sand going to get any colder? Well, I want your student to think about what's the temperature of the freezer right now.
Negative 15.7.
And where is the sand located?
In the freezer.
Yeah, I wish I had a picture of that so you guys could see that.
That's what I was.
Yeah, the sand and the water are both
That's
inside the
question I
freezer.
Okay, that was the question I received.
Okay.
So I have a freezer over here.
Is there any way to get a picture of the setup?
Yeah. I think I took one. Let me see. If I did, I'll email it to you real quick.
Okay.
The problem is I didn't. Yeah, let me do it after the next. And I'll open the door real quick if you want and take a picture of the inside, but that's going to affect the data, which is all right.
No, we'll wait. We'll wait. I'll show
Okay.
them. I'll show them after lunch.
Okay, perfect. Yeah, and by the way, class, I am going to let this experiment run all the way through lunch. So I want you to predict now. Write it down. What do you predict the water and the sand temperature to be after lunch?
20.
Write down your predictions.
Write it down. You have your scratch
What
paper.
temperature do you predict? All right, new temperatures. 2.7.
Negative 15.5 and 1.0.
How long is lunch?
Not long enough.
That's weird. I wonder what's going on with the sand. All right, so I'm gonna
Oh, look,
I'm
water
gonna sign off now because we got to get ready to go to lunch. Or actually, I'm not gonna sign off. I have to keep going because I need the. So in case you're curious about the technology class, signed into Google Hangouts using my login, and I've got my iPad also in the same with my same login. So that's why you see 2 Jerrys in the room, because there are.
That's a Jerry
So
squared.
that's how I was able to. Yeah, that's how I was able to not have to. That's how my lazy butt can just sit in this chair and look at data. I don't have to get up and look at the data every 5 minutes.
Mr. Gordon, no. Oh yeah.
Are you saying I'm lazy?
I wonder.
Tell me a secret.
I love technology.
Yeah, this is fun. Now,
Yeah.
are you able to
And
see
I
our
wish
class?
we would have planned this. We'll have to do this again the next time we do an experiment.
Absolutely, and likewise.
But we'll have to.
Did you catch that one?
All right. So I'm gonna turn my camera off now because I got to get my class ready to go to lunch.
All right, and we're gonna sign off. By the
Bye,
way,
everybody, thank you.
we've recorded this.
I'll leave everything going. I just won't have my camera on.
All right, we've been recording this as a screenshot, so we're gonna save it and be able to watch it again later. All right, give it a nice.
Awesome.